Hello everybody. Continuing our scientific notation here. This is going to deal with adding and subtracting numbers in scientific notation. So our learning targets, of course, we will add numbers expressed in scientific notation and subtract numbers expressed in scientific notation. So let's jump right into a couple examples. We want to consider the expression 4.2 times 10 to the third plus 2.9 times 10 to the third. So part A, let's change the numbers into standard form and then add the numbers together. Okay, so 4.2 times 10 to the third would be 4.2, and we'll move the decimal 3 times. 2, 3, so we'll be there now. So we'll put in 0. So the first number would be 4,200. And then if we want to add 2.9 times 10 to the third, 1, 2, 3, would be 2,900. Okay, and if we want to add those two numbers together, we are going to get, so 42 plus 29 should be 7,100. Okay, and can we write our answer that we just did in scientific notation? Okay, so 7,100, if we want to write that in scientific notation, we would need to put a number between 1 and 10, so it would need to be written as 7.1 times 10 to the, and let's see if we were right there with the decimal, it would have to move 1, 2, 3 times. So it should be 7.1 times 10 to the third power. All right, so let's take a look at another example here. Example A. Can we add these numbers keeping them in scientific notation? So instead of transforming them into standard form, what if we just add them in scientific notation? So let's take a look. If we were to add the same numbers, okay, so look, we're going to add the 4.2 and the 2.9 right down here, okay, so we added those and got 7.1. Now, basically what it says, in order to add or subtract these, the exponents must be the same. So in our problem, they were both times 10 to the third, so both exponents were the same. So if we just simply add the 4.2 and the 2.9 like we did right here, keep the exponent the same, right? They were both 10 to the third. Okay, notice our final answer was 7.1 times 10 to the third. So if the exponents are the same, we should be able to just add the other factors and then keep the exponents as is. So let's take a look at a couple more. Let's do the try these down in the bottom of the page here. So try these A. Oops, let me get a marker here. So if we want to do 2.3 times 10 to the 9th, and we want to add 5.6 times 10 to the 9th, okay, since both are times 10 to the 9th, we are able to just simply add the first value, the first factor. So 2.3 plus 5.6 is going to get us 7.9. And then since both values were times 10 to the 9th, that's good, right? They're both the same. We can just leave that alone and keep it as times 10 to the 9th. Okay, if we want to do one more, let's just do a subtraction problem. Part B, example B, 9.1 times 10 to the negative second power. Okay, so I'm going to put that in parentheses just because it's a subtraction. And we're going to subtract another number in scientific notation, 2.5 times 10 to the negative second power. Okay, and remember, with all these, one option is to just write them in standard form, like we did the very first one, then subtract them, and then turn that back to scientific notation. But this one, we may not have to do that because take a look, both numbers are raised to the same exponent. They're both times 10 to the negative second power. So all we would need to do is take the 9.1 minus 2.5, and then we know that we can keep the exponent the same. Okay, so 9.1 minus 2.5 is 6.6. And again, since they're both raised to the second times 10 to the second power, we can just leave our answer alone. Okay, and that's going to be a quicker way. But again, if you're ever a little uncomfortable and you don't want to take a chance with the tricks and shortcuts, you can always go scientific notation and then, turn to standard form, right, and then convert your answer back like we did at the very top of the page here. All right, let's keep looking. This one kind of continuing with our solar system examples. So it's a good science application, right, for scientific notation. So Mercury is the closest planet to the sun, and Neptune is the farthest planet. Okay, and again, I guess Pluto doesn't count as a planet anymore. Back in the day when I was in school, Pluto was the farthest. All right. So, anyways, they're giving us some values here. Neptune is 2.8 times 10 to the ninth miles away, and Mercury is 2.6 times 10 to the seventh. Okay, and Colton and Drake wanted to find the distance between the two planets. Okay, so we're going to have to subtract their distances from the sun, right? That's going to be the difference, or the distance between the two, is if we subtract them. So they each went about it different ways. If you take a look at Colton's strategy here, okay, 2.8 times 10 to the ninth minus 2.6 times 10 to the seventh, he kind of did method one, where we just converted each to standard form by moving the decimal, and then actually subtract the numbers, and you'll get the, 2,774,000,000. And then he did have to convert that to scientific notation in the end. Okay, while Drake was able to get the same answer, he never really went to standard form. Okay, but notice what he did do. Okay, if you remember the property, the rule, if you're going to keep them in scientific notation, you need to be able to write them so they're both times 10 to the same exponent. So originally, right, of course they were not the same. One was times 10 to the ninth, and then one was times 10 to the seventh. So what Drake did, he just decided on converting one of them so that it would match the other one. So notice that the 2.8 times 10 to the ninth is equivalent to 280 times 10 to the seventh. Okay, so he was able to do that, and then use the fact that since the other value was times 10 to the seventh, now you can just subtract the 280 minus 2.6, and you can just keep the 10 to the seventh. But then he did notice that that was not scientific notation either, because it's 277.4. So in order to actually get it in scientific notation, he did have to adjust the decimal point, right? We need the number to be between 1 and 10. So he had to move it back. So that involved a lot of, kind of going back and forth, conversions and things like that. So it's going to be up to you to decide which method you want to use. Okay, so let's do an example and kind of see which method we might like doing better. So number 3 here, Earth is the third closest planet to the sun. It's 9.3 times 10 to the 7 miles from the sun. Let's find the distance from Neptune to Earth. Okay, so let's see if we can figure this out. I'm just going to do some work over here. So Neptune, again, its distance to the sun was given above as 2.8 times 10 to the ninth. And Earth's distance to the sun, they just gave us in this problem, was 9.3 times 10 to the seventh. Okay, so again, we can decide, do we want to just go to standard form, write all the zeros out, okay? Or is it going to be easier for us to get them in the same exponent of 10 and then just subtract? Okay, we can do both methods too. All right, so let's go ahead and let's do method 1 first. So method 1 would be to change them both into standard form. So 2.8 times 10 to the ninth power. I would need to move that decimal 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 zeros, right? So it would be 2 and then 8 and then 1, 2, 3, 4, 5, 6, 7, 8 zeros. 2, 3, 4, 5, 6, 7, 8 zeros, right? Now Earth's distance, if we converted it to standard form, is 9.3 times 10 to the seventh. So 1, 2, 3, 4, 5, 6, 7. And that would leave 1, 2, 3, 4, 5, 6 zeros. 2, 3, 4, 5, 6. Okay, so I'm going to subtract these on a calculator because, again, there's a lot of zeros there. 1, 2, 3, 4, 5, 6, 7, 8, minus 93 with 6 zeros. All right, and that's giving me an answer of 2707 and 1, 2, 3, 4, 5, 6 zeros. 2, 3, 4, 5, 6 zeros. Okay, so that's an answer, okay, in standard notation or standard form. So scientific notation, the decimal place would have to be between the 2 and the 7 there, so it would be 2.707 times 10 to the, how many digits would be after that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, times 10 to the 9th power. Okay, and that may be the best way to do that. That way you're not kind of messing around with converting things back and forth 3 or 4 times. Using Drake's method over here, it's not crazy complicated, but I think it might just be a little bit, there might be too many little small areas for mistakes. Colton's method, I would say, would be the way to go. But again, you're free to do it either way that you want. They just wanted us to choose either method we wanted. And I kind of liked Colton's method a little better myself. Okay, so just to do a quick little recap on the check your understandings here. When the numbers are given to you, right, and they both are raised times 10 to the same exponent, it's going to be pretty straightforward. All we would have to do on something like that is just add the 2.5 plus the 4. Okay, so that would give us 6.5. And then we just leave the 10 to the power alone as long as they're the same. Okay, it's only when they're not raised to the same power. So in your assignment, when you guys have to do like number 10, when one is raised to the times 10 to the 9th and one is 10 to the 8th, that's when you're going to want to decide which method you want to do. And it might be in your best interest just to change those to standard form like the previous example. Or if you want to, you can try and write them both with the same exponent just by adjusting it a little bit. But again, I'm kind of suggesting the first option because this involves less issues. Okay, so that's adding and subtracting scientific notation.